Hello all, my name is Pratham Chandratre and welcome to my YouTube channel. So guys, in today's video, we are gonna understand the four main types of machine learning. And this is super important video guys, because before we deep dive into machine learning algorithms, let's suppose linear regression, logistic regression or clustering algorithms, this lays as a foundation for all the machine learning algorithms guys, because the types of machine learning and how they are differ from each other, what are their characteristics, how they work, these all things are super important to understand before moving forward in the machine learning. So without wasting any time guys, let's start our video. So at first, what are the four main types of machine learning? The first is supervised machine learning, second is unsupervised machine learning, third is reinforcement learning, and fourth is semi-supervised machine learning. Now how these different types of machine learning works guys, these all things we will discuss in this video. So let's first start with supervised machine learning guys. So see, in supervised machine learning, basically we train our model with a labeled dataset. Now what is labeled dataset? See guys, in the dataset we have two features. First is independent features and second is dependent features. Now what are independent features and what are dependent features? Let's take one example. We are making one machine learning prediction system which is diamond price prediction. So basically we will take the input features from our user and then we will predict the price of a diamond. So now what are the input features which decide actually the price of a diamond? That is, first is how much carat is our diamond is. If diamond is of 4 carat, if diamond is of 5 carat, if diamond is of 1 carat, if diamond is of 0.25 cents, means as much as the carat will increase of the diamond, the price of the diamond will increase, and as much as the carat will decrease, means if diamond is of just 0.25 cent, just 0.50 cent, then price of the diamond will decrease. So on the carat, the price of the diamond is dependent. Okay. Then second comes the color of the diamond. How is the color of the diamond, how much fluorescent it is, means the price of the diamond is also dependent on the color of the diamond, and also how much clarity the diamond is it of VVS clarity, how is the clarity of the diamond, and on that also the price is dependent. But guys, these three are our input features, and based on these input features the price of the diamond will be dependent. And these three, carat, color and clarity, are independent feature because they are not dependent on anything. Like clarity is not dependent on any feature, color is not dependent on basically any feature, and carat is also not dependent on any feature. So these three are our input features and they are independent, and price is basically dependent on carat, price is basically dependent on color, price is basically dependent on clarity of the diamond. So price is dependent feature, and this is what our output feature is guys. So basically we call our output feature as dependent features and we call our input features as independent features. And this, see, basically what I have said, in machine learning, in supervised machine learning, we train our machine learning model with a labeled dataset. Now what is labeled dataset? Labeled dataset is a dataset which consists of both independent features as well as dependent features. Now means, let's suppose we are training a supervised machine learning model for diamond price prediction, means we want to predict the price of a diamond. So during training of our supervised machine learning model, we will train our model with both input features as well as output features. That is, we will provide our machine learning model both input features and output features. That is, along with carat, color and clarity of a diamond, we will also train our machine learning model with the price of a diamond. So what it will basically study: if carat price is 4 carats, if color is fluorescent, and if clarity is of VVS clarity, then price of the diamond is gradually increasing. And as the carat decreases, as color is not good, as clarity is not VVS clarity, then price of a diamond basically decreases. So it will basically learn from this during the training step. And then when we provide our test dataset, that is, what is training dataset, what is test dataset, this we will cover in our next video. But just understand that when we provide our new features, when we provide new input set to our machine learning model just to test it whether it is basically giving us proper answer or not, optimal answer or not, at that time we will basically give just input features, and based on these input features it will predict the price of a diamond. So now you have basically understand what is exactly supervised machine learning. Just again a small recap guys. See, supervised machine learning is a type of machine learning technique wherein we train our machine learning model with a labeled dataset. Now, what is labeled dataset? Labeled dataset is basically a dataset which consists of both independent features as well as dependent feature. That is, in supervised machine learning, we train our machine learning model with independent features which are our input features as well as dependent feature which are our output feature. So this is basically the supervised machine learning, guys. Now in supervised machine learning, there are two types of problem statements which we are solving. So first is, I have mentioned here, guys, first is regression problem statement and second is classification problem statement. So basically in supervised machine learning, we provide both independent features as well as dependent features to train our machine learning model. Now speaking ahead, in supervised machine learning, we are basically solving two types of problem statements. First is regression problem statement and second is classification problem statement. Now how these both regression problem statements and classification problem statements differ from each other, let's see that, guys. See, speaking about regression problem statement, guys, here our output feature is continuous value. Like as we have seen, basically our example of diamond price prediction. In diamond price prediction, guys, basically we give carat, color and clarity of the diamond and basically we get the price of a diamond, which is our dependent feature. And this price of a diamond, guys, is basically our output feature. And this output feature is continuous value. As we can see that price of a diamond is not like, binary value like 0 or 1. Price of a value will be continuous value, whether it would be a 1 lakh rupees diamond, whether it would be 1.25 rupees diamond, 1.25 lakh rupees diamond, whether it would be a 1.50 lakh rupees diamond. So it is basically a continuous value. It's not a classification, it's not a binary value. So basically this in which the output is continuous, this basically we called it as a regression problem statement, guys. Example is sales prediction, house price prediction, then diamond price prediction. So this basically where you get output as a continuous value. At that time we basically make use of regression algorithms like linear regression. Then there are decision tree which you can use for both regression problem statement, classification problem statement. Then moving ahead towards classification, guys, these are basically the two types of problem statements of supervised machine learning. Basically regression and classification. Now we have learnt about regression. Now let's see about classification. Now in classification, guys, our output feature is basically in classes, guys. Like see, here our output feature, let's take example, one example so that you get a clear understanding in an easy terms. See here we have both independent features and dependent features. So here we are basically creating a system which will basically predict that whether a student will pass in an exam or whether a student will fail in an exam. So let's take example of independent feature as play hour and study hour. So these are basically the input feature which we will take from the students. Like there is a one student who input as I play for 9 hours and I just study for 2 hours. So our system predicts that the student will basically fail. It's obvious, guys. And if the student play hour is just 2 and student study hour is 8, the system predicts that the student will basically pass. Now as you can see, guys, this is our dependent feature and this is our output feature. And here there are just two classes, like the student will pass or the student will fail. So such type of output feature wherein there are the classes, wherein our output features are divided into classes, at that time we basically called it as a classification problem statement. Wherein our output feature is not continuous value, our output feature is divided into classes like pass or fail, like whether a customer will churn or customer will not churn, whether our email is spam or a ham, means not spam. So this type of problem statements wherein our dependent feature, our output feature is divided into classes, that basically is called as classification. So speaking about supervised machine learning algorithms, guys, there are various machine learning algorithms that comes under supervised machine learning, like linear regression, ridge regression, lasso regression. Then there is logistic regression, there is decision trees we use for both classification, regression. Then there are various boosting techniques like ADA boost, XG boost, extreme gradient boosting. Then there is random forest, then there is gradient boosting, there is Naive Bayes, there is support vector machine, there is k nearest neighbor, which is basically used for classification purpose. So there are various different types of algorithms which comes under supervised machine learning, wherein we provide both independent features as well as dependent features to train our machine learning model. Now moving ahead towards unsupervised machine learning, guys, see, In unsupervised machine learning, first of all, we train our machine learning model with unlabeled dataset. Now you have got a understanding, you have got some understanding of labeled dataset is basically wherein we train our model with both independent features, that is input features, and dependent features, that is output feature. And in unsupervised machine learning, guys, we train our model with actually unlabeled dataset. Now what is unlabeled dataset? Unlabeled dataset is the dataset which contains just independent features, that is just input features, but there are no dependent features on which we train our machine learning model. That is, during training of our machine learning model, we don't provide output features to train our machine learning model. We just provide independent features, that are input features, to basically train our machine learning model. And in unsupervised machine learning, guys, there are two types of problem statements which we are catering. First is clustering technique and second is dimensionality reduction. Now in clustering technique, basically we group the similar kind of data together in a single cluster. And in dimensionality reduction, guys, our main aim is to reduce the higher dimension features to a lower dimension. Like for an example, if there are 1000 dimensions of data, then we will lower it down to 100 dimension with the help of principal component analysis, with the help of linear discriminant analysis, which comes under unsupervised machine learning. So here basically we train our model with an unlabeled dataset. To take an example, guys, there is one great example and popular example of clustering, which is customer segmentation, wherein we group the customer segments, wherein we group the customer based on their salary and their expenditure. In our dataset, basically in our x-axis we have taken salary and in our y-axis we have taken expenditure. Now here based on the salary, guys, if here this cluster basically says that the salary of an employee is basically less and their expenditure is also basically less. This cluster basically says that salary of the employee is less, but the expenditure of the employee is basically high. This cluster basically says that salary of an employee is also good, expenditure is also good. This cluster basically says that salary of employee is very high, but expenditure of the employee is not that too much. And our company means there is one company, the company main target is to focus on those customers who have high expenditure power, so that there wherever we will launch a product, we will give extra 20% discount to the persons whose expenditure power is more, so that once they see the discount of 20%, they will actually buy the product as soon as possible. So that is our main aim of the company. So for this only, guys, see how magically this customer segmentation really works, guys. So here basically we have got our target audience, that basically expenditure power is more. So this basically, this is the one cluster, these are the people whose expenditure power is more, and also these are the people whose expenditure power is more. So what is this, guys? This is basically clustering. Here we have cluster the similar kind of a data points in a single cluster. Now this all data points are similar, like this all data points have less salary and more expenditure. This all data points are similar, like these data points have more salary and these data points have more expenditure. So here we have basically cluster the same kind of a feature, same kind of a data together in a single cluster. So here we have basically our main aim is to find the target audience. So we have got here our target audience, and we will basically give 20% discount to this audience, and then they are most likely to buy the product as their expenditure power is more. So this is basically what the power of unsupervised machine learning, guys, where we train our machine learning model with an unlabeled dataset. That is, we don't provide actually the output feature to our machine learning model during the training purpose. We just provide our input feature, and our machine learning model learns by itself. It finds the patterns by itself. Now there are various unsupervised machine learning algorithms available, guys. Like for the clustering, there is K-means clustering, then there is DB-scan clustering, which is density-based spatial clustering of application with noise. Then there is hierarchical clustering. These different types of clustering techniques wherein we group similar kind of data points together. Then for dimensionality reduction, guys, there is principal component analysis, there is linear discriminant analysis, algorithms, techniques available for unsupervised machine learning, guys. Now before moving towards semi-supervised machine learning, guys, if you want to connect with me for a one-to-one personalized guidance, I have put the link in the description, guys, where you can book a session with me or a top mate. So just a short intro about me to know whom you are learning from, guys. I have basically completed 13 internships in artificial intelligence domain at top organizations like Amazon, IBM, EY, Infosys, etc. I also earned 24 global certifications, which you can check on my LinkedIn profile as well. And I was also able to crack 6 job offers in less than 60 days in an AI ML domain. And recently, I was also featured on Times Square, guys. So if you want direct mentoring, career advice, personalized learning, artificial intelligence roadmap, or a project guidance, feel free to connect with me on TopMate. Link is in the description, guys. Now moving ahead towards semi-supervised machine learning, guys. Now what is semi-supervised machine learning? As the name itself suggests, guys, it's basically semi-supervised machine learning. Means it's not completely supervised and also it's not completely unsupervised. So here basically we combine our supervised machine learning algorithms and unsupervised machine learning algorithm. So here two types of learning techniques are basically getting combined, which is supervised machine learning and which is unsupervised machine learning. Now there might question arise in your mind, how these two techniques are basically getting combined. Like in one technique you have basically say that we provide labeled dataset, in other technique you basically said that we provide unlabeled dataset. So basically guys, semi supervised machine learning techniques, machine learning algorithms are basically used at the time when we have some features as labeled and some features as unlabeled. Like for an example, let's take example of spam classification, wherein we are predict whether our email is spam or ham. So basically here, as you can see, our basically we have a data set of 10,000 features. We have data of 10,000 features, and out of 10,000 features, our 4,000 features are labeled data set and our 6,000 features are unlabeled data set. Like out of 10,000 features, our 4,000 features are basically labeled. That is 4,000 features has the email body, and basically it says that email is a spam, and 6,000 features has just a email body. We don't have actually the output feature present in that. So for the 4,000 features who have the email body and the output feature, for that basically we make use of supervised machine learning, guys, wherein we have an email body. If the email body contains the words like congratulations, you won a lottery of 7 crores, so basically the output is basically the email is a spam email. So basically it will consider that, it will learn from that 4,000 features with the help of supervised machine learning algorithms. Like there are various supervised algorithms which I have told you before. So based on that supervised machine learning algorithm, it will basically learn on that 4,000 features which are labeled dataset, and then remaining 6,000 features who don't have the output features, that is unlabeled dataset, then based on that training dataset, then on the unlabeled dataset we basically make use of unsupervised machine learning technique. So this is where basically semi-supervised machine learning basically comes into a picture, wherein we combine both supervised machine learning and unsupervised machine learning, guys. Now moving ahead towards our final fourth type of machine learning technique, which is reinforcement learning, guys. See, reinforcement learning is a machine learning paradigm where an agent learns to make decisions in an environment to maximize the reward symbol. It's like a trial and error learning process where the agent explores the environment, takes actions and receives feedback, that is which are rewards or penalties based on the actions it has taken, allowing it to learn optimal behavior over time. So I have basically read out the definition for you, and by just listening to the definition only, most of you have got the meaning that what is exactly reinforcement learning. So see, first of all, it is basically a type of machine learning technique, and here our agent, now what is actually agent? Agent is basically the learner, the machine learning model, the learner, the decision maker who is basically going to take the decision, who is basically going to learn. So that is basically agent, that you will understand more as we move ahead in this video, wherein I will explain you the example of reinforcement learning. So it is basically the type of machine learning technique, guys, wherein our agent actually learns by interacting with the environment. Like instead of being told the correct answer, like we have basically given the correct answer in our supervised machine learning, wherein we provide both independent features and dependent features. That is, we also provide our output features during the training, guys. So unlike that, guys, in our reinforcement learning, the agent basically tries action and then learns from the feedback. Agent basically learns from trial and error process, guys, and based on the feedback, if it has performed good, it will basically rewarded, and it will basically get the reward, and if our agent has performed bad, it will basically get the penalty, guys. So here our ultimate goal is to learn a policy means a strategy in reinforcement learning that actually maximizes our long-term rewards, guys. So think of it like trial and error loading, guys, wherein our agent learns by trial and error, just like how humans learn to ride a bicycle. In the same way, our reinforcement machine learning algorithm works, guys. Now just look at the key concepts of what are the in which the reinforcement learning actually works. So first is basically agent, guys. As I have already mentioned, guys, agent is basically the decision maker or a learner. Let's take example of Chase AI so that you get a better understanding of exactly what is reinforcement learning. So see, in Chase AI, what does basically happen, guys? On the other side of the board, there is a human playing, guys, the real human playing, and on the one side of the chessboard there is a AI, there is a AI model which is basically playing. So this AI model, whether it would be like a AlphaZero, have you heard about AlphaZero, guys? It's basically a chess AI model. It's basically a chess AI player. So on the one side of the chessboard there is an AI player, on the other side of a chessboard there is a real human. So basically agent is basically that AI model, the chess AI player who is playing on the chessboard. So he is basically going to take a decisions completely on its own. He is basically also a learner who has basically learned millions of steps in the chess. So this is basically called as agent. Now moving ahead towards the environment, guys, this is actually the world the agent actually interacts with. So example is basically the chessboard, the opponent, the rules of the chess on which our agent basically interacts with. So this is basically known as environment, guys. Now moving ahead towards actions. So action is basically the move or a decision the agent can basically take, guys, like in our chess, whether moving a knight, whether moving a rook. So this is basically different types of actions which basically our AI agent can basically take. After that there is a reward. Now what is actually reward? Reward is basically the feedback from the environment, guys, after an action is basically taken. So if basically our action is taken good, so if let's suppose if our agent has basically win the game, so it will get +1 point. If our agent has basically lose the game, he will get a -1 point. And if our AI agent has basically means the game has basically been drawn, so at that time 0 will be our point given to our AI chess player. Then there comes basically state. State is basically the current situation, guys, that is actually been taken, like the current board setup, position of all pieces on the chessboard. This is basically the current state. So that is basically known as state, guys, in reinforcement learning. So that's all about different types of machine learning technique. 4 types of machine learning techniques. I have written too much of content. I know video is quite lengthy, guys, but it's actually most important video of machine learning. So because after this, guys, we will go ahead with machine learning algorithms. At that time there comes this word. This words frequently will come in your learning, guys. So for that only I have made this video lengthy, in depth, so that you get a clear understanding of exactly what are different types of machine learning and how actually they work and how actually they differ from each other. Also, guys, I have one good news for you. I have recently launched my brand new Udemy course on Pydantic. So for the first 100 learners who will enroll in the course, with the link in the description, will get the course for just ₹499. So grab that deal, guys. It's an amazing course. I have put lot of efforts, and believe me, Pydantic is such a skill in 2025. I have seen lot many interviews of machine learning, AI engineers. Pydantic, the questions from Pydantic are coming frequently, guys. So believe me, that course will be one of the best course of your life. So grab that course at just ₹499 for the first 100 learners who will basically enroll in the course. So that was all about today, guys. All the 4 types of machine learning I have tried to explain each and every machine learning, guys, technique, whether it would be a supervised machine learning, whether it would be unsupervised machine learning, whether it would be a semi-supervised machine learning, or whether it would be a reinforcement learning. So if you like this video, if you like the depth of the video, if you like the teaching style of the video, hit that like button, guys. Also subscribe to our YouTube channel, as in future there are too many tech content coming out for you guys for absolutely at no cost on YouTube. And also share it with your friends who wants to learn machine learning, who wants to learn the depth of everything, every topic available under machine learning. So I will see you in the next video.